Molar mass and conversions. Using molar mass to go from one unit to another. So calculate the molar mass of lithium carbonate. The way you find molar mass is always from the periodic table. You always have molar mass there. When looking at the periodic table, the mass written underneath the particular element is that mass of moles. For example, on the periodic table under carbon, it says 12.01. That means I have 12.01 grams of carbon over 1 mole of carbon. The molar mass is the mass written on the periodic table per 1 mole of that particular element. So then if you have a compound, you just sum up all of the molar masses to get the overall molar mass of the substance. So let's look at this example. Calculate the molar mass of lithium carbonate. So this is an ionic compound, and we have the 8 ending. So this is a polyatomic ion, not just a nonmetal. I know lithium is +1. Carbonate is CO3 2-. So in order for this to come together, it will form Li2CO3. So then, when calculating the molar mass, you account for all of the amounts of each substance. So lithium carbonate has 2 lithiums plus 1 carbon plus 3 oxygens. You do not have to do it like that. For me, I like to organize how many I have of each. So then you just plug it in. You go to the periodic table and you look for the molar mass of each of the substances. The molar mass of lithium is 6.941. Now, a lot of the times, grams over mole. A lot of the time, 2 things happen. Students look at the periodic table, find the molar mass, and just write grams. Now, you cannot forget about the fact that it's grams over mole. That becomes really important when it's being used in conversions. It's always grams over mole, no matter what. Another question that comes up is how many significant figures to use. A good rule of thumb is to use 3 or 4, 2 to 3 after the decimal, just to use as many digits as possible so that you can get the accurate answer. Now we have 1 carbon times the molar mass, 12.01 grams over mole, and 3 oxygens, 3 times 16.00 grams over mole. You multiply those through and sum everything together to get that the molar mass of lithium carbonate is 73.89 grams over mole. You have your unit, you have your compound, and you're finished. So whenever you're just looking at molar mass of an element, you just look at the periodic table. If it's for a substance, a compound, you sum up all of the masses that you have from the elements, including the subscript. So you know, for this case, we had 2 lithiums, because the 2 was written here, that belonged to the lithium, and the 3 oxygen, since the 3 was right by the oxygen, not the carbon. Now, molar mass, because it's grams over mole, can be used as a conversion factor. You can use it to find grams or moles. So, let's look at this next problem. A box of salt contains 737 grams of sodium chloride. Now, let's pause and breathe here. What's sodium chloride? I know sodium is Na+, chlorine is Cl-, so sodium chloride will be NaCl. How many moles of sodium chloride are present? So I'm given 737 grams of sodium chloride, and I want moles. Now I'm in the same compound. I don't need to use a mole ratio, and I want to go from grams to moles. Whenever going from grams to moles of the exact same substance, you use molar mass. So what do I know? I know my molar mass always because I can look at the periodic table. I sum together the molar mass of sodium plus chlorine. That gives me 58.44 grams over mole. I believe that for sodium, it is around 22.99 grams per mole, and for chlorine, 35.45 grams per mole. I sum those together and I get around 58.44 grams per mole. Now I start with what I'm given, 737 grams sodium chloride. Now I use my molar mass as my conversion factor. Now if I want moles, my 58.44 is not going to go on top, it's going to go on the bottom. Since it's always over a mole, 1 mole of that substance, I put 1 mole NaCl on the top and 58.44 grams of sodium chloride on the bottom. Then my grams sodium chloride cancel out, and my answer is 12.6 moles NaCl. I have 3 significant figures, my unit and my compound. Note, if I was given moles and going to grams, I would not have flipped the molar mass. You use the molar mass just like when you have the conversion of Avogadro's number or you're using mole ratio. It's always what you want over what you are trying to get rid of. Knowing that molar mass, the number with the grams is always on the top and it's per 1 mole, always.